Hello, welcome again to the continuation of tutorial on Surds. This time around we are going to look at addition and subtraction. So we take our first problem, simplify each of the following. We have 3 root 2 plus 4 root 2, 5 root 12 plus 2 root 3, root 28 plus root 63, and 2 root 125 plus 3 root 20 plus 4 root 45. So we start with the A part of the problem. This is a similar surd, or you call it like surd. Like in algebra, we can add and subtract like terms, but we cannot add and subtract unlike terms. So the same thing we are going to do here. We are going to add and subtract similar or like surds. The surds here, they are in the same square root, so they are similar or like surds, so they can be added and subtracted. So like here, this common surd is root 2. So these rational numbers before the roots are added together. So we have 3 plus 4 giving us 7. Then we now bring in the common root, that's root 2. So we go to the B part of the problem. 5 root 12 plus 2 root 3. Now you can see what we have inside the square roots are not the same. So what we do is we see if we can get a factor of 12 that is a perfect square. Then we now first write this 5 root 12 in basic form of surds. So and here we have a 4 times 3 to give us 12. So we have 5 square root of 4 times 3 plus 2 root 3. And from here, since square root of 4 is 2, we multiply by 5 to give us 10. So we now have this one as root 3. So the explanation is very clear. Square root of 4 is 2. 2 times 5, 10. Then we now be left with square root of 3 here. So we have it as 10 root 3. Then plus 2 root 3. So here we say 10 plus 2 gives 12. So 10 plus 2 gives 12. Then the common root is root 3. So our answer here is 12 root 3. So we go to C part of the problem. For the C part of the problem, we have square root of 28 plus square root of 63. Here again, we write square root of 28 and square root of 63 in basic form of surd. So here this is 28 4 times 7. So we have it as 4 times 7, root 4 times 7. And here is going to be root 9 times 7. Root 9 times 7 plus root 9 times root 7. So square root of 4 is 2. So we have this as 2 root 7. Here square root of 9 is 3. So we are multiplying it by root 7. So we have our answer as plus 3 root 7. So again, 2 plus 3 gives 5. So we have 5. Then we add the what? We bring in the common root, which is root 7. Therefore, root 28 plus root 63 is 5 root 7. We go to D part of the problem. 2 root 125 plus 3 root 20 plus 4 root 45. And what we have inside the square roots also are not similar. So we are going to look into it and see if we have any perfect square can divide them. So like here I have 125. Yeah, 25 goes into 125 to give us 5. So I have 2 square root of 25 times 5. Then this is 3 root 20. 4 times 5 will give us 20. That's going to be plus 3 root 4 times 5. And here it's very clear. So we have 9 times 5. So we have 4 square root of 9 times 5. So square root of 25 is 5. 5 times 2 gives 10. Then root 5. Square root of 4 is 2. 2 times 3 gives 6. That's plus 6 root 5. Square root of 9 is 3. 3 times 4 gives 12. That's plus 12 root 5. Then we now add them. They are now similar or like surds. So this is root 5, root 5, root 5. So we say 10 plus 6 giving us 16 plus 12 gives 28. So we have our answer as 28 root 5 as the final answer to problem D. With this, we have done justice to the first problem. We go to the second problem. The second problem, we start right away from problem 1. Again, this is a similar surd. This is root 3, this is root 3. So we can subtract them. So 5 root 3 minus 3 root 3 is 5 minus 3 gives 2. Then the common root 3. We are done with A. The B part of the problem, 5 root 18 minus 7 root 2. Okay, with these two, it means we can express 18 as basic surd of 2. So we now have it as a 5 square root of 9 times 2, then minus 7 root 2. Square root of 9 is 3. 3 times 5 is 15. So I have 15, then root 2 minus 7 root 2. 15 minus 7 gives 8. So we have 8, then the common root 2. So 5 root 18 minus 7 root 2 gives 8 root 2. We go to the C part of the problem. C part of the problem, this is 5424. This is 9 times 6, 4 times 6. Yes, we can express them as basic surd of root 6. So here is going to give us square root of 9 times square root of 6 plus square root of 4 times square root of 6. Square root of 9 is 3. So I have this one as 3 root 6. Square root of 4 is 2. So that's going to give us minus 2 root 6. So from here, 3 minus 2 gives 1. So our answer is just root 6. Because it's not mathematically presentable to write 1 root 6 as a final answer. Maybe for the purpose of calculation and explanation in a problem, you can just put the 1 to help you do the operation, but as your final answer, it is root 6. So we go to D part of the problem. 2 root 288 minus 3 root 18 minus 2 root 8. To get the similar surd that we can express each of them into, we start from the smallest number. 8 is 4 times 2. 4 is a perfect square. So meaning this one, if we divide by 2, we get the perfect square for this. Divide by 2, we have 144. So we go, this is 2 root 144 times 2 minus 3 root 9 times 2, then minus 2 root 4 times 2. So here, square root of 144 is 12. 12 times 2 is 24. Then root 2. Then square root of 9 is 3. 3 times 3 is 9. So minus 9 root 2. Square root of 4 is 2. 2 times 2 is 2. So you have it as minus 2 root 2. So we now have a similar or like surds. 24 minus 9 gives 15. 15 minus 4 gives 11. So our answer is going to be 11 root 2, since the common root is root 2. With this, we've done justice to the problem, and that is the end of this tutorial. Till we come your way again, remember to subscribe to our YouTube channel Oninab Resources, like and share this video. With that, you get more of our videos. Goodbye.